Hi, I'm currently doing Paul McWhorter's Arduino R4 Wi-Fi lessons, and lesson number 9, that's annoying there, lesson number 9 is displaying the LED status using the serial port to print the serial monitor. So it's all very simple. It's just that if it's on, I say it's on, if it's off, it's off. We will run this program. Right, it's compiled, it's uploaded, and there we have the LED flashing nicely, but you need to turn on the serial monitor and it's saying LED is on, LED is off. So the only way that you can really check whether it's working is if I say on when it comes on, and we'll see whether it comes on. So it goes on, on, on. Well, that's lucky, it works. Right, so after looking at that, I thought I was interested in looking at the serial print in more detail. So I will close the monitor on that, because otherwise it causes problems, and look at my next program, which is here. And I'll make it bigger because I'm fed up with watching that blink. Right, I have defined various variables, an int, two longs, a float, and a boolean, and then I'm not doing anything in the loop because otherwise it carries on printing and printing and printing and printing. I've done everything in setup, so I'm just saying this is from the serial print, and then I'm printing out my integer and then the value of it, my long 2, my long, like that. And then at the end of the line it is printing out my bool. I defined my bool up there as false, but if you just print it out, it will print out as 0, or if it's true, it print out 1. So I've also included another line there that is on a new line, and it's printing out my bool. And this bit here is quite handy. That is shorthand for saying if my bool equals true, then if it's true, you take the first bit there within the what do you call them? Double quotes, yes, sorry, my mind went completely blank, and you return that to the print line statement, and otherwise it's false. So we'll just show what happens there. Right, just saying from serial print, yep, and then all that lot is going on one line. So it's my int 42, that's right, my long 1,000,000, no, next one 0, my float. Now I put that in as 3.1415926, and it's defaulted to be 2 decimal places, which is annoying. But then my boolean is 0, and then the little bit there has done it right, so my boolean is false. Now that is very long-winded, so I thought there must be a better way of doing it than having all those stupid print statements. So the first one that I found was a thing called sprintf, and here we go, it's those 3 lines there that you use, and what you do is you can combine in there all that you want to print. You're actually printing my int colon space, and then that %i looks for the parameter after there, and it says my int, so it puts the value in there. Then it's printing out my long doop doop doop, and then it's looking for the next one, which is a long, and then that's another long, and then the float. All pretty simple. And once you've put it in the buffer, it you use a Serial.print to print the buffer. So we'll see what happens. Copy those lines. Right, I'm still doing the first bit, so it shows, did I put the buffer up there? Oh no, and before you do that, you need to define the buffer up here, and I'm allowing 60 characters in the buffer, plus you need an extra one to tell the functions that you've reached the end of the buffer or whatever. So we'll try running that. Right, that's the first bit. Now that says from sprintf. My int, that's right, that's right, that's right. My float, it can't cope with printing out a floating point number, which is stupid. I didn't print out the my ball, so it isn't that it's gone missing. I just didn't do it. So look at that. You think, what's the point of that? If it doesn't work properly, there's no point in using it. And the other problem that I have with it is you're allocating that amount of memory for your buffer, and you might be, because an Uno doesn't have a lot of storage, then perhaps this isn't a good idea. But there's a worse problem. If you make that buffer smaller, now those are more than 20 characters long. So if I'd written sprintf, stop it, I would have said, oh, you're trying to put more into it than you've got room for. But no, watch this. It has gone over the end of the buffer and now it's going bonkers. Now that is stupid. So I'm not ever going to use sprintf in my life ever again. Right, if I move that back to that, upload it again, it ought to mend it. Yeah, but it still doesn't have the my float working. It still can't cope with that. Now the second option. Now people at, I can't remember who they were, someone has written a thing where you can download it and it's called Arduino printf. But if you look in the library, it isn't called that. It is, oh, take it back to work. It is called LibPrintf. So all you have to do is you click on the books there, then you can filter your search, so you go LibPr, and it says, hello, LibPrintf by Embedded Artistry. Thanks, Embedded Artistry, jolly good chaps. And I haven't removed there because I've already added it. If you haven't already installed it, it will say install. So you just press install and then you can close that. And once you've got it installed, what you can do is you have to include it at the top. So I'll copy that line up there. And then I'll include a couple of these. We'll start off with the first two lines, like that, and there. That ought to work. Now, again, that is, does that look? Yes, that looks exactly the same as the sprintf, only you aren't using the buffer. You don't need the buffer for printf. And I've put my ball on the end. So we'll just try it and see what that happens. Right, that's from the original serial print, that's from the printf, and look, is coping with that floating point number now. Don't know why, but if you can't trust it to always do it, then there's no point. So from printf, it is exactly the same, only it's got my ball equals 0. Right, that works brilliantly. Right, we'll put in my final 3 lines and see what this does. Now, it says 4 preceding blanks, leading zeros, and many dodgy decimal places. So, for my int, which is 42, instead of just having %i, I put %10i, which means it's allowing 10 characters for that. So it puts in 8 leading spaces, and then that, the dot 0.9 li means that it's adding leading zeros. I haven't done anything to the second long number, and the my float, I've just added loads more. You have to look up the exact syntax of that. That's adding loads more decimal points. And then my boolean, I'm having it as a string, and when you look at the end, I've got this syntax of if it's true, you print out true, if it's false, you print out false. And just to make it look more interesting this time, I made that true. Then on another line, I'm printing the width of %*i, depends on the first parameter, and that means that you're printing out my int there, but it's looking at the parameter before, which is at 4, so it's allowing 4 spaces, 4 characters for that. So it will be space 42, because my int is 42. But we will just test that and see what happens. Right. That was as before. My int, that's padded it out with 8 spaces beforehand. That's padded it out with 2 leading zeros. I didn't ask for it to do anything there. And my float is put in loads of decimal places, but if you look to see what it was, I said that my float was 3.1415926, and it's decided to make up a few. But that is the problem with storing things as floating point numbers. That isn't actually a problem with the printf. So it's a thing you have to be aware of. And then, as opposed to printing out just the 1 or 0, it's printing out true. And here, as we expected, it's put in 2 spaces there. So after looking at that, I think you would agree that sprintf isn't worth bothering with, because it's got too many pitfalls. Serial.print and Serial.print line is fine to use as long as it's simple, but it becomes tedious and boring if you've got too many of them. I will pause the video now and I'll come back and I'll show you how you can use Serial.print or any of the other ones to debug programs in an efficient way. Don't go away. Just going back to my first program for a minute. Now, line 14 to line 19 is just deciding whether to print out whether the LED is on or the LED is off according to state. And I showed the shorthand way, so I just wanted to prove that that does work. So if I just copy that line in and get rid of all of those there. That ought to be equivalent, so we'll just try running that to see whether it works. Yep, the LED is flashing. We'll just have a look at that. On. Yep, it's working perfectly. Just thought I'd show you that. Now, if you look at line 4, int LED equals 12. Now, you'll never be changing the LED to another number in the middle of the program. So what you can do is put const. Now, theoretically, you ought to have, if you have constants, that ought to be capital, but I'm not changing the program. And we'll see whether that works. Yep, still working, which is great. Now, there's another way that you can achieve the same thing. Instead of const int LED, you can put in hash define LED 12. Now, anything that begins with a hash up the top there is not part of the program as such. It's part of the preprocessor. And what it does is, with a define, it will, before it compiles, it will go through the whole program, and every time it finds LED, it will replace it with 12. So we will just see whether that works. Yep, it's still working. And if you hover over where it says LED, it actually says it's a macro, and it tells you what LED is defined as. Now, that you might think has nothing to do with anything, but it will come in useful when I'm showing you my next program. I've turned off the serial monitor. Right, we'll go on to my next program, which I'm covering up that annoying flashing, which is good. Now, when you're debugging, one of the easiest ways to debug something is to just use a print statement to say where you are. Now, I know nothing's likely to go wrong with this program, but if, say, you wanted to put in some debug statements, you could go like that. Whoops. Sorry, there, that's better, and I've left a line in between there, and I will put in another one there. So all that does is, well, I'll show you what it does. Need to put on the serial monitor. Right. So it's just printed that starting setup and finishing setup. What good is that, would you say? Well, it is very useful if you put in a variable, whatever, to see what your myint was or anything. But you've used your Serial.print or Serial.print line statements to work out where your errors are, and then after you've finished, you think, oh right, I'll just delete them. But I might need them again. So should I comment them out? Oh, I don't know. Or I could put in something that is always going to be there, so I can turn it on or not. So you can go hash define debug 1, which works exactly the same as when I did it with LED. And then you could put in if debug. Like that. So then it will only do it, it will only print that starting setup if debug is on. So we will try that. Right, debug was on. We will put debug equals false. And there, it hasn't printed that. I didn't put the if debug around that one. So that works wonderfully. But that is making your program bigger because you've got 2 extra lines and it slows the program down. So neither of those are ideal. So we'll dispense with that idea. So we're left with the dilemma of, do we leave that line in so it runs it? Do we take it out completely and then if we want to debug again there's a problem, or do we comment it out? But there's a better way. Just as you can define debug wherever you have debug in the program, it replaces it with naught, you can do something similar with this. So we can just say debug line and debug line. Try uploading that. Ugh, doesn't like that. And that's because I haven't defined it. So we'll go up here and we'll go define debug line. And if you look at it, it has got something in a bracket. So you go, and then you can put anything in there. You could put A, B, C, but I'm putting X because it makes sense. Define debug line as Serial.print line X. And for good measure, not that I've got it in the program, we'll just have a debug and a print line like that. And that ought to be okay. So that ought to say, wherever I see debug line X, replace it with Serial.print X. And if you hover over there, it says it's a macro with debug line and you replace it with that. So we will do that. Right, close my serial monitor, open, right, okay, there, it says starting setup. From that, so it works exactly the same, it's made the substitution, but that hasn't got round the problem that you sometimes don't want it. So you've defined debug, and then you can go, anything with a hash is a preprocessor, so you can go if debug equals 1. You don't need a semicolon or anything, or a curly bracket, because this is a preprocessor. Then you define debug as that. I'll put a space there. Right. Will that work? No. No, because you need endif. Will that work? And is closed my serial monitor. Open. Right. So that's still working. We're debugging, because debugging is 1, which is true, and so it's printing that out and printing that out. But what happens if we go debug equals 0? Oh, debug line not declared. Right, so that means you have to, if debug equals 1, you do that. If you put an else, and then you need to decide what you want to do if you aren't debugging. Do you want to print out that starting setup and finishing setup? No, you don't. So you want to do nothing. So that is what you do. Every time, if you've got debug false, every time you find that, you just replace it with nothing. So it just goes serial begin, blah, 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 nothing, blank line, then it goes on. So we will see whether that works. Come on, come on. Right, it hasn't printed anything out. Great. We'll change it back to 1. And it's back, which is wonderful. So that actually stops you having, it means you don't have to go through all your program to say, right, I'm going to get rid of that line or comment it out or put it within an if statement. And all that you have to do to turn debugging on and debugging off is change 0 to 1 or 1 to 0. And I think that's pretty damn good. And it also helps because when you look at your program, admittedly, the compiler will say, hello, that is actually a serial print line. When you look at your program, you can very easily say, that's a debug line, that isn't part of the program proper, and that is a serial print line. And so it's easier to keep in your mind what you're using for debugging and what you aren't using for debugging. Now there's one other thing. This was uploading it with debugging on. So that's 2082 of program storage space and 298 of dynamic memory. If you turn debug off and load it, the sketch uses less memory, less program storage space. It was 2092, I think, and that was 298. So this is brilliant. It means you can turn debugging on and off as you wish. You can always identify a debug print line as opposed to a serial print line, and when you aren't debugging, your program's smaller and your storage is smaller. And you can actually expand this if, say, you had a program and you wanted to have the option of whether you want to beep or not, depending on, sometimes you might want to just display a message, sometimes you might want to beep, sometimes you might want to do both of them. So you could just have a function called beep and call it, and then you could have a hash define beep 1 and 0, and it would either beep or it might not beep, but it's just a concept. But the easiest way to do it is to not go and put all this stuff in after you've written your program. If you always put that in at the beginning of your program, then you can always use the debug line and the debug by itself without having to worry about it. So as opposed to the bare minimum, this is bare minimum plus debug. Hope this helps.